So you're telling me if you make the mass bigger, then
Why don't you understand, Kevin? Why don't you understand?
I just don't get it. What's the deal with pendulums?
I've been teaching physics for 15 years, and I've never met a student as incompetent as Kevin. What's he doing? Alright, Kevin, this is the last time I'm going to talk about pendulums with you.
Okay.
So, explain to me what pendulums are.
Chapter 1, The Boy Who Lived. Mr. and Mrs. Dursley of number 4... Wait, sorry, wrong page. A pendulum is something hanging from a fixed point, which, when pulled back and released, is free to swing down by gravity.
Alright, so you got that down. So, look at this pendulum. What does this remind you of? You idiot! This reminds you of a metronome.
Yes.
Cut to the clip of metronome. Alright, pendulums can also be used as counterweight to prevent and lessen the effects of earthquakes. And they also have a lot of everyday use. Alright, so let's try measuring the period of this pendulum right now. Alright, 3, 2, 1. Alright, Kevin, how many seconds?
Well, it's 1.08 seconds.
And so now if I increase the length of this pendulum, we'll see what happens to the period, okay? You ready?
Yes.
Alright, 3, 2, 1. Alright, what was it, Kevin?
Well, it's 1.33 sequence. It's
So-
like kind of bigger than the time from before.
Yeah, that's right, Kevin, because in the pendulum equation, the period is proportional to the square root of the length. So if we increase the length, the period gets longer.
I think I can solve this worksheet now.
So I think I'm finally making some progress with Kevin, and hopefully by the end of the year, I'll be able to at least raise his grade to a passing score. Right?
Hey, can you check my work?
Sure.
No!
Kevin, that's a wrong equation. Last time I'm telling you this, mass doesn't matter in the period of the pendulum. Look, this is an equation for the pendulum. Do you see where M is? Where's M, Kevin? Tell me. Where's M?
It ain't here.
Of course M is here because M doesn't matter when you're trying to find the period of the pendulum. Okay? Alright, so we're gonna see what changing the mass does to the period of the pendulum. Three, two, one. What do we get, Kevin?
Oh, bro, it's the exact same.
Exactly. And it's the exact same because, like I showed you, mass has nothing to do with the period of your pendulum. So what do you think is going to happen if we change the gravity of the pendulum?
I don't know.
Alright, Kevin, let's go in. So when we go up on the elevator, the gravity changes, so we're going to see what this change has on the period of the pendulum, okay? What do we get?
The time period's decreased.
Right? And that's because gravity is increasing, so therefore that means that the period of the pendulum decreases. So now do you see what gravity does to the period of the pendulum?
Yes.
Do you know how pendulums work now?
Yes.
So are you confident that you can ace that test tomorrow and get a C?
Yes.
Alright.
Whoa, bro.
Quick recap. This is the pendulum equation. Remember that a pendulum is an object hanging from a fixed point that when pulled back and released is free to swing down by gravity. Here are the variables that go into a pendulum equation. T, time, also known as the period in which the pendulum completes one oscillation from one side to another. L, the length of the string or whatever is being used to connect the mass to a fixed point. This is affected by a root relationship to the period. G, gravity, is the acceleration of the environment. Earth's natural acceleration of gravity is 9.8 meters per second squared, but we can manipulate this by going on an elevator, where acceleration can change slightly, and this is affected by a 1 over root relationship.
Alright, Kevin, it's test day.
Okay.
Good luck, dude.
Oh, I don't remember how to solve this. Can you? Oh, right, yes. There's no change. Oh, I don't remember how to solve this also. Can you solve it? Oh, right. It's square root 1 over 2 times the old period. Okay, last question. Oh, wait, I don't remember this. Do you know how to solve this problem? Right, it's square root 2 times the period. I'm finished.
Wow, Kevin, let me see your answers. Done already? Haha. No change. Root 1 over 2 times period. Root 2 over... Kevin, you finally understand how to do pendulums now. Hey, congrats, buddy. You can finally pass the class. Just like all of you guys. Yay!